What is water and why is it so important? Water covers 2/3 of the surface of the Earth. Water occurs in all three phases on Earth: solid, liquid, and gas. It represents half of the contents of all biological cells. It is the conduit for the function of major biological mechanisms. In searching for life on other planets, it's the primary building block that is sought after. The availability of drinking water is shrinking around the world and is a pending future crisis. The hydrological cycle of evaporation, condensation, precipitation, and surface collection is fundamental to life on Earth. Water vapor is the most abundant greenhouse gas in the atmosphere. It accounts for as much as 70% of Earth's heat retention. It is water's unique molecular properties that enables it to perform so many functions. Water's molecular structure. The formula for water is H2O. The oxygen atom is located in the center with 2 hydrogen atoms bonded to it. Each hydrogen has 1 valence electron that it shares with oxygen when they bond. Each oxygen has 6 valence electrons. It shares 1 valence electron with the hydrogens to complete the bonds. This leaves 2 lone pairs of unpaired electrons on the oxygen. The 2 bonds with the hydrogen atoms and 2 lone pairs of unpaired electrons form a tetrahedral structure around the oxygen. The oxygen is called sp3 hybridized in this form. The tetrahedral structure gives water a bent shape with bond angles of 104.5 degrees instead of a linear shape. In addition, it imparts polarity to the water molecule, meaning it has a positive end, hydrogen side, and a negative end, oxygen side. This also causes the hydrogen atoms to have a slight positive charge and the oxygen atoms a slight negative charge. Water's unusual boiling and freezing points. When water molecules are together, they arrange themselves so that the slightly positive hydrogen atoms are close to the slightly negative oxygen atoms. This allows water molecules to form covalent bonds between each other. These bonds between molecules are called hydrogen bonds. Oxygen is in group 16 of the periodic table. Hydrogen combines with other atoms in this group to form molecules like H2S, H2SE, H2TE, etc. The combination is called a hydride. As you move up group 16, boiling points of these molecules tend to decrease because the molecules are getting smaller. For example, the boiling point of H2TE is negative 40 degrees Celsius, while the boiling point of H2S is negative 620 degrees Celsius, and can be a gas at room temperature. We know that it's not the case, and water actually boils at 1000 degrees Celsius. The reason for the change in trend is the hydrogen bonds in water. The strong hydrogen bonds that hold the water molecules together must be broken to cause it to boil. The same trend occurs with freezing point. Once again, as you move up the periodic table, freezing points for H2S, H2SE, H2TE get lower and lower, with H2TE being negative 490 degrees Celsius and H2S being negative 840 degrees Celsius. However, water once again breaks the trend due to its hydrogen bonds by freezing at 0 degrees Celsius. In addition, when water freezes, turning to ice, the hydrogen bonds cause molecules to create a lattice. This lattice is less dense than liquid water, causing ice to float on water. Were it not for its hydrogen bonds, water on the surface of the Earth, in plants, our bodies, etc., would be a gas. There would be no hydraulic cycle. Life on Earth would not exist as we know it. Why is water called the universal solvent? The polarity of water imparts another unique characteristic to water. It gives water the power to dissolve many substances. In fact, water is often called the universal solvent. When a substance or solute is put into water, the hydrogen atoms in water align themselves with the negative atoms in the solute. Likewise, the oxygen atoms in water align themselves with the positive atoms in the solute. The pull in opposite directions by the hydrogen and oxygen atoms causes the solute to break apart or dissociate. Because water dissolves so many substances, truly pure water is uncommon and most contains minerals. For example, many people struggle with hard water in their homes that contains calcium and magnesium compounds dissolved in it. Some substances, like oil, do not dissolve in water. These substances are called hydrophobic. These are just a handful of the many unique properties of water. These unique properties come from water's molecular structure. This is how water derives its special characteristic that make it a building block for life itself. Water's function as a universal solvent makes it apt to be polluted by man. Knowing how important it is, we must protect water as if our life depends on it.